Oh, let's look at these guys. There's a lot of ways to look at parallel lines, right? You'll notice this parallel line is this graph, which is shaded up, and this graph, which is shaded down, and they never actually cross each other, so there's no solution there. Notice this guy already. He has a same slope, different y-intercept. So let's do this one. This guy crosses at -2 and has a slope of 1, like that. This guy has 4 and a slope of 1. He's a solid line, so let's get his solid line. We've got our boundary lines going here. But they'll never touch, so let's see where they shade. The one with a slope of 4 shades down. I'm sorry, the one with a y-intercept of 4 shades down. And the one with the y-intercept of -2 shades up. So what we're getting is we're getting the whole thing shaded, but in between, right here, there's a double shaded area that would be the solutions. Solutions are all the parts between, right? Between the parallel lines and on the solid line, right? Not this one. Dotted lines means it's not a solution. So there it is. Let's graph this guy right here. Both have a slope of -2. Let's get this one with -3 first. So if I cross at -3 and then I go down 2/1, I'm going to solid line. I'm going to look something like this. Just going to graph the boundary lines. It's the same thing but crosses at 1. So it's going to have a similar slope, something like this, both solid lines. The one that crosses at -3 shades down, like this. The one that crosses at 1 shades down, so it's single shaded here, but then out here it's doubly shaded right below it. So the solutions are beneath both lines and on lower line. So it's beneath both lines down here and on this lower line. Let's do one more. Right? This one, they both have a slope of 1/3. This one crosses at -6 right here. That's up 1/1, 2, 3, and it's dotted. So let's do a nice little dotted line here. This one crosses at 5 right here. It's up 1/1, 2, 3, and it's solid, right? The one down here shades down. The one down here shades up. And there's no solutions. There you have it. They got to have an overlapping region. I think we have one more page. It's just this, actually. So it's just some questions. So let's look at those questions. Is it possible for a linear system to have every point on the solutions, yes or no? Well, if it's the same line shaded in the same direction, we would definitely have to say yes on that, wouldn't we? So the answer would be if it's possible for two linear system inequalities to have every point in the plane as solutions, why or why not? I would say if both represent the same inequality. You know, that wouldn't work anyway. If they both were the same inequality, that'd be no. The ordered pairs will never work. I'm going to cross this off. No. Alright. Each boundary line is two half planes. It is impossible for both to cover all numbers. That is true. Can't cover all numbers with two half planes because it's got to be in both interacting. Sorry about that up there. I have to think about it. How do I how would you write a system of linear inequalities from a graph? write an equation for each line represented. So if they gave us a graph, we just take each line and write an equation, turn that into an inequality. How does telling the specific ordered pairs tell you that the solutions are graphed is correct? Alright, we need ordered pairs from a region that is in the overlapping area. I'm done. We're at homework. Talk to you soon.